Hello, everybody, and welcome back to Math 100. In this video, we will begin Chapter 3, and we'll start from Section 3.1, which is about simple and compound interest. We will spend most of our time studying compound interest, which is what Chapter 3 is all about. Okay. Now, needless to say, money, finance, and compound interest. These are some of the most practical topics we will learn in this course. All right, so let's get started. We will start with the basics of compound interest in section 3.1. As I just said, section 3.1 is on the two types of interest and the basic ideas behind those two types. One is called simple, and the other is called compound. All right, and we will spend just a little time on simple interest and most of our time on compound interest. Okay, so the first thing I need to mention is that we need to distinguish the first two sections, section 1 and section 2, from the other two sections that would follow immediately the sections 1 and 2, because in the first two sections, our emphasis, our calculations will be always on a one-time deposit. All right, so you put your money, we call that amount the principal. We deposit that money into an account once, okay, not a series of payments such as paying back the loans or saving up for the future. All right, so we are talking about a one-time deposit, not a series of payments. This is something very important for you to keep in mind. Now get your calculator out, okay? If you have an iPhone or a smartphone, it probably comes with a calculator. If you hold it in sideways, that may become a scientific calculator, which is what you need. Okay, so make sure, and you will be using this key quite a bit, probably in every question. This key is called the caret key, which will help you find an exponent or find an expression with an exponent. This is also the same as x to the y. Sometimes in old calculator, you may have y to the x. All of these are the same, and you will be using this key probably more than any other key on your calculator. Okay, as I said, there are two types of interest, simple and compound. What is simple interest? Well, that's simple, okay? Well, what makes it simple? This type of interest is called simple because the same amount of money is added at every period. So this is a linear growth, right? So you start with some amount. This is time t. Here's the amount. It's going to grow by, let's say, $5, $5, $5 every year. And so it's going to just have a straight line. And this is called a type of linear growth. In contrast, we have compound interest. And what happens in compound interest is that the money or the amount is going to increase by the same percentage. And this is, of course, your annual percentage rate. But because the amount grows and that future amount, let's say after 1 year, you're over here, and then the same percentage, not the same amount, is going to be added. So the following year, you'll have more, and then you'll have more. And so the percentage, the base, or the reference number of the percentage gets bigger and bigger. So even though the percentage stays the same, the growth will be more like this, which is called exponential growth. Now, exponential growth is something that we will be studying over and over again. This will appear again in chapter 6 and also in chapter 7. So this is one of those themes of this course. It will be a theme throughout the course. All right, we need some symbols because we'll come up with some formulas, pretty much two basic formulas. And one is, the second one is what you really need to know to do most of your problems on homework as well as on your exam. Okay, all right, so what's the first symbol? Principal. Okay, now the principal is how much you're going to put down. That one-time deposit I was talking about, okay? So the one-time deposit is denoted with capital P, standing for the word principal. And then we have an APR denoted with a lowercase r, and that r stands for the word rate, right? And this is called the annual percentage rate. Now, it is sort of misleading to call this the annual percentage rate because it is not quite the rate of yield for per year. Okay, but we'll talk about that in a minute. Time, how much time is the money going to be left in a bank account? That time would be denoted with T. We used to call this capital N in the old version. Now we use T for the number of years, okay? And then the future amount is called A, again, A standing for the word amount. And so this is what we will be looking for in most of our exercises, all right? A, what is the future amount? If you deposit the money, the P number of dollars at the annual percentage rate of R for time T in years. All right, let's do a comparison of these two different types of growth of money. Suppose you have an account, well, two accounts, okay, and you have $100 to deposit into each of the accounts. One grows, well, and by the way, both we assume 5% annually, but one is with simple interest of 5%, and the other is the simple interest of 5% compound interest. Okay, now year 0, what is that? That's now. This is the time you deposit your $100. So of course you'll have $100 in both of these. Okay, now after 1 year, what's going to happen? Now remember, 5% of $100 is pretty simply $5. Okay, so this is the amount under the simple interest scheme. $5 is what you will be adding every year. All right, so here the amount is going to be 100 plus 5, and that's 105. And in the second year, now remember you added 5 after the first year. So for the second year, you are going to add another 5, and that's of course 2 5s you are adding. And third year, you have 5, 5, and then another 5 is added. Now you may be wondering, why don't we just take the previous amount and add 5 to it? Yeah, that it will define a recursive formula, but what I'm interested in is a more general formula, and that's why I am writing it this way. After 4 years, how many 5s? Well, you have 4 interest payments of $5 each, and of course that's 120. You get the idea. After n years, you add to your original initial deposit, to that amount, you add n times $5 because you are giving, or you're getting $5 in interest for n years, once a year, right? So you can write that number as 5n, which means 5 times n. Okay, so that's the formula for simple interest. You see that it's not going to be very difficult. N, sometimes this number 5 is called a slope. If you think of n as your variable x, this is a linear equation. You may have learned about these things in your Algebra 1 class. This is called the slope. 5 is the slope, 100 is the y-intercept, which is the initial value. Now, compound interest works in a very different way. P is 100. After that, okay, so adding 5%. How do you do that? Okay, well, we learned this in chapter 2, right? Adding 5% means multiplication by 1.05. Now, why is that? Well, because adding 5% means you're calculating 105% of the base number. All right, so after 1 year, you take that 100, multiply that by 1.05. And that's going to give you $105. You say, well, that's exactly the same as under simple interest. And that is absolutely correct. Okay, so I should tell you that the compound interest is exactly the same as the simple interest if only one compound period is involved. Okay, that's one a fact that you may want to keep in mind. But everything is different after that. All right, so let's see what happens after 2 years. So this will be after 2 compounding periods. You take now a new base, 105, and then you add 5% to that, not the 5% of the original $100 as in the simple interest case, but now the base changes. The base number is 105, which by the way is 100 times 1.05, right? This is 105, and then you multiply this whole thing by 1.05 again. So you notice that I multiplied 100 by 1.05 twice. And if you calculate this, you get 11025. Now slightly, just slightly more than under simple interest. Did you get the idea? For the third year, you take this entire amount, which was $110.25, which I'm going to write this way, 1.05, 1.05, and then another 1.05. I keep multiplying by 1.05, right? And so the factor of a new 1.05 as a factor appears one more time in every single instance here. And so this is really 1.05 raised to the third power multiplied by 100, okay? And this is going to give you 115.76. You have to round this to the nearest cent, and this is what you get. Now, I think you get the idea. 1.05 is multiplied 4 times together for the amount after 4 years, and then you multiply that by the initial payment or initial principal of $100. When you do this calculation, and I will show you how to calculate this on a scientific calculator, which I will share on the screen with you in just a second. But do this part first, because this is according to the order of operations, 1.05 to the fourth is the first thing you calculate, and then you multiply that by 100. This will amount to $121.55. Again, $1.55, slightly more than under simple interest. The formula, which we will write, is why is that 1.05? Well, that's because 5% was my annual percentage rate, APR. So 1 plus R, and you raise it to the nth power, and that is the formula, right? Okay, so what happens after 100 years? Well, 100 years, everybody that we know today is going to be dead. Maybe somebody is going to inherit this money. Look what happens with simple interest. The amount after 100 years, remember, you're only getting $5 regardless for 100 years. Okay, now we do this part first. That's of course $500 in the total interest payment. Adding to the original 100 is $600. So 100 years from the beginning of this balance, you will get $600, or whoever is going to get $600. Under compound interest, remember, money grows exponentially. So here, according to this formula, you take 100, and it's 1.05 raised to the 100th time, right? And this is going to be, watch, $13,150.13. So compared to $600, this is a huge amount of money, starting with $100 with a modest interest rate of 5%. The money increases exponentially, and after 100 years, the account is going to have over $13,000. Okay. Now, the simple interest, we will probably finish talking about that right now. Okay, because now the point is we want to talk about the compound interest exclusively. That's what we will be talking about, right? So you see the formula. If you have annual compounding, which means it's once a year at the rate R, it's pretty simple, right? All you have to do is to calculate, multiply the principal, P, with 1 plus R raised to the Tth power, where T is time in years. So that's pretty simple expression. Now, this is not the formula I want you to learn, because there will be another more general formula, which will be coming on page 2. But before we go to page 2, I want to demonstrate, these are sort of a sophisticated calculations that I have done, and you may not be familiar with how to calculate these things. So let me show you how to do these calculations on the scientific calculator. Okay, so here's what a scientific calculator looks like. Yours may look slightly different. What I pulled out here is the scientific calculator that comes with my Surface Pro, the Microsoft Surface Pro, which is the type of device I use. And this is in the operating system, so you probably will have something similar if you have a Windows-based machine. But you can have a standard calculator like this. That's, the 4 simple operations, but you can change it to a scientific or programmer calculator. This is a scientific calculator. How do you know it's scientific? Well, because you have things like pi and e and squares and square roots and x to the y. Now, this is the key I was talking about. Okay, now pay close attention to this because I will be using this quite a bit. Okay, so $100 deposit, 5%. For 4 years, how much are you going to get under the interest rate of 5% compounded annually? The answer is you have $100, right? So it's $100 times, notice here on my calculator, it'll tell me what I have entered. So in case you made a mistake inputting the information, you will notice right away. Now, what am I multiplying it by? It's 1.05 raised to the power of, that's the x to the y key, raised to the power of, did I put 1.05? Raised to the power of 4. And I don't know if I got this right. Yes, I didn't do that because 1.05 was not entered. So let me go back, and again, you can tell, yeah, there you go. I didn't get the right answer, and the answer doesn't seem to be right because money, $100, is not growing. So go ahead and do it again. 100 times 1.05. I think I was talking too much and I forgot to enter 0.05 raised to the power of 4. Okay, now your calculator already knows that the exponentiation part is going to take precedence over the multiplication. Your smart device or smart tablet is so smart that it already knows that the exponential expression needs to be evaluated before that simple multiplication. So just by clicking or hitting the equal key or the enter key, this is going to give us the answer of $121.55 rounded to the nearest cent, which was what we wrote under that balance for the 4th year. All right, and then let's do this for the 100 years. Let's clear this. CE clears all that. And this time I'm going to put 100 times 1.05 raised to the what power? 100th power. Okay, and equal sign, and that is going to give us that last amount we discovered, which was $13,115.13 rounded to the nearest. You see that rounded to the nearest penny. Okay, so that's how you do it. Now, this is okay, but when things get a little more complicated, let me show you what I normally do. Remember, I said that the most complicated part is the last part. Okay, so I put like 1 plus 0.05 and then equal to 1.05. That's inside of the parentheses. All right, this is the base to which I have to take the that exponent to evaluate. So then I take x to the y, let's say for the 100-year balance, so 100. So what I'm looking for first in this case is 1.05, 1 plus r, raised to the 100th power first. Okay, and then at the very end, I do that multiplication. In this case, multiplying by 100 to give us to find the answer. Okay, so get familiar with this key in particular so that you can do these financial calculations. Now, is this important? Are you going to ever use this? Like in math class, typically a math student always asks, when are we ever going to use this algebra? Well, this is not algebra. When are you going to use compound interest ever? Let me tell you, you will probably use compound interest for the rest of your life. Now, you may not be the one calculating it. Your bank may not be the one calculating it because they all use computers. Okay, but this is how it works, and you should know how that compound interest works. And if you have a scientific calculator with a simple question like this, I think you should be able to do this on your own. Okay, so with that, let's go to the second page of this notes for 3.1, and we will look at the second and the more important formula for compound interest.